Alright, so we now derived that variational lower bound called L, and we will try to maximize L. That will happen during training. So I drew the autoencoder here. We have input X and here X reconstructed. This is the encoder decoder. Both are neural nets of which the parameters need to be trained. And here you have that famous function Q of Z. Actually it's Q of Z given X. Yeah. And here you have Px given Z. And so the big idea is that instead of having a deterministic vector Z, you're gonna have a probabilistic variable. Yeah. And so we start from X here in the bottom. Remember, X comes from a distribution P of X, and we don't know P of X. So basically what we will do is we're gonna assume that we have a Gaussian here. Yeah. So we're gonna sample Z from, we're going to sample Z from Z given X, and Z given X is going to be a Gaussian. It will have a mu and a sigma. Yeah. It will have mu and sigma Z given X. Alright? So here we have mu of Z given X, and here we have sigma of Z given X. Alright, so that gives you the variable Z. Now here we're going to decode the message, and here again we're going to sample X, or your X reconstructed from Z, yeah, from X given Z. Yeah, and X given Z again we will assume is normal with a mu and a sigma, and here of course we have X given Z. So here we have mu X given Z, and here sigma X given Z, and then at the end it will give you your X reconstructed. Yeah. So that is the whole idea of variational autoencoders.